Hello mathematicians, hope by in this video you can say I can represent proportional relationships by equations, tables, and graphs. Let's look at one example in this video. So it says a car is traveling at a constant speed of 300 miles in 4 hours. Write an equation to represent the relationship between miles traveled m and hours h. So what we need to do here is we need to find out what our unit rate is. And, well, we know that they travel 300 miles in 4 hours, so we could find out what our unit rate is by taking 300 miles and divide that by 4 hours. Miles per hour, right? So over 4 hours. And, well, so we take 300 and divide that by 4. So we take 300. I need a little bit of long division off to the side over here. Divided by 4, and 4 goes into, well, it doesn't go into 3. It does go into 37 times. 7 times 4 gives you 28. Borrow there. Bring down the 2. Bring down the 0. And 4 goes into 25 times. So our unit rate is 75 miles per hour. So every hour they drive 75 miles. So in the problem it says, write an equation to represent the relationship between miles traveled m and hours h. So in this problem, the miles traveled would be our dependent variable, where hours is our independent variable. Okay, so they're going to travel m miles. So m is equal to 75 times h, so 75h. So our equation would be m equals 75h. So now that we've got our equation, we can fill out a table here in order to graph this equation. So h is hours and m is miles. So let's fill out 4 different points here. Let's say after 0 hours, 1 hour, 2 hours, 3 hours, and let's throw a 4th hour on there. Okay, so now in order to fill out the rest of this table, well, we'd go m is equal to 75, and h right here, we're trying to find out when h is equal to 0, so we substitute 0 in for h. We know 75 times 0 is indeed 0, so we get 0 right there. And now the same process, we go as m is equal to 75 times 1, and that is equal to 75. And now when h is equal to 2, so m is equal to 75 times 2, and well, we could use some multiplication off to the side here, but I'm just going to do it in my head. 75 times 2, that is 150. So we put 150 right here. When h is equal to 3, we get m is equal to 75 times 3. And that is equal to 225. So we put 225 right here. And, well, if we could plug our value in when h is equal to 3, but we already know that at 4 hours it traveled 300 miles, so we technically don't need to do this, but we'll do it anyways. So we know that m is equal to 3 when h is equal to 4. So now we get to graph this table here. And, well, our h is our independent variable, so that's going to replace, well, what we typically would call our x-axis. So our h is right here. This is our h. And our m is our dependent variable, so that is our y. So m would go up here. And now we need to kind of label our graph to make it fit. So let's go every 2. So let's say this is 1 right here, and this is 2. This is 3, and we go up to 4, so let's say this is 4 right here. And let's count by 50s. Let's go every other one. So we're actually counting by 25. Let's count every other one. So let's go to 50, 100, 150, 200, 250, and 300 way up here. Okay, so this is our graph now that we have it labeled. Well, 0.00, that's easy, that's right there. All right, point 175. So we go over 1 and up 75. So it's right between 50 and 100. So it'll be right there. 2, 150. So we go over 2 and up to 150. Over 3 and up to 225. So between 200 and 250. And now 4, 300. So you go over to 4 and up all the way up to 300 right here. Okay, so this would be how we would graph this equation that we wrote based off of this situation here. So that is it for our video. Hope you're watching this and getting in a little bit of practice. You can say I can represent proportional relationships by equations, tables, and graphs.